The diagram shows a piece of wire bent to form the parameter OABCO of a sector of a circle, center O with radius R, and subtended angle AOC is equals to theta radians. The wire is of length 100 cm, which says that the entire parameter here is 100, and R and theta may vary. So find the value of R for which the area enclosed by the wire is a maximum. Okay, so how do I go about doing this is I know that when I see the word maximum, this will suggest to us that likely this is a differentiation problem on the subtopic on maxima minima. So the area is a maximum. The value of R, this will give you a hint that you are probably finding dA dr equals to 0, right? So if we are finding that dA dr, you know that the next earlier step right before this, we will need our A probably as a function of R in order for us to conduct our differentiation. So we now go ahead to look at how we can calculate or determine and unlock A in terms of R. Now this is a sector. So recall that the area of a sector here is half R squared theta. Okay, so at the moment now, we don't have A in terms of R because there is a theta here that is forming a second variable. So what I want to proceed to do next is to rearrange or sub away this theta, okay, to put it in terms of R. And we need to look to the question to see what's the information that allows us to sub away this theta. Okay, so for the question itself, right, they will tell you that the parameter of sector O 100 cm. So that is telling you that the parameter, which is 100, is the same as 2R, okay, because you have 1R, 2R, and this itself will be R theta, right? Because we are talking about arc length. Okay, so in case you forgot why this R theta come from, this is called the arc length. This is the arc length formula for the sector. So why do I form this is because this information will allow me to put theta in terms of R so that I can sub it back into the area of sector. I now proceed to simplify and group and make theta the subject. Okay, subtracting 2 out on both sides. Now dividing by R on both sides, I can get my theta to be 100 minus 2R over R, which is the same as 100 over R minus 2. Okay, so this can be equation 2, that can be equation 1. I now proceed to sub equation 2 into 1 simply because I want to have my A in terms of R like we originally arranged and agreed upon so that we can do our dA dr based on the question requirement. So the area of sector now is equals to half multiplied by R squared multiplied by theta, which is now replaced with 100 over R minus 2. This is the same as 50, eventually 50R minus 2, so R squared. Okay, oh sorry, 100 over 2, correct, 100 over 2, yeah, 100 over 2, 50R minus R squared. Okay, so from here, what I do next is I take dA dr, since remember we agreed upon finding the maximum value of the area, right? So dA dr means if I were to differentiate 50R minus R squared, which gives me 50, differentiating R gives me a constant, differentiating R squared gives me 2R. Okay, and I will equate this to 0. Since we are finding a stationary value, which in turn may give us the maximum value, to find a stationary value of A. Okay, so solving this just gives us 50 equals to 2R and R equals to 25. All right, using the second derivative test, right? So what do you want to do is, because after we found the stationary value, right, this does not guarantee that it provides us a maximum. So it could be a maximum, it could be a minimum, or it could be a stationary point of inflection, right? I find my second derivative d2a dr square, which turns out to be differentiating of dv dr, dA dr, which is 50 minus 2r. That just gives me negative 2, right? So indeed, I don't even have to submit my r. You can see that. Therefore, r equals to 25, right? Gives the maximum area of the sector. Okay, so I've done part 1. The corresponding value of AOC in degrees. Right, so what is our theta? AOC is over here. So I proceed to sub it. We know that earlier on we have defined theta as 100 over r minus 2. Right, so remember calculus, we always do it in radian form. So here we're supposed to do it in radian form. After that we convert it back to degrees, right? So if I sub my r to be 25, my theta turns out to be 100 over 25 minus 2, which is 2 radian. So to convert this to degrees, right, what I need to do is I need to multiply by 180 over pi, which gives me 360 over pi degrees, which is the same as 114.6 degrees to 1 decimal place. All right, so this is converting from radian to degrees. I need to multiply by 180 over pi. So in case you forgot, let me just do a quick crash course at the side. If our answer is in radian mode, right, and I need to convert it to degrees, right, the idea is that radian is always in terms of pi. So if I want to get rid of the pi, I will multiply 180 over pi. So 180 usually is a nice number for degree, pi is for radian. But if I want to convert from degree to radian, I multiply by pi over 180. Okay. So next, now given that this is a completely unrelated question. Okay, so given that b here, now we're looking at b, y equals to 2 over 3 x cubed plus 5 over 2 x power negative 2, 2x squared minus 2 over x. Find the two values of x for which y is stationary and show that the larger of these values correspond to a minimum value of y. Okay, I think this question is relatively simple, so I will not be going through. Okay, thank you.